Hi guys, welcome to lesson 6.1 on slope and rate of change. So this is a little bit of a long one, but I think most of it will be stuff that you're already familiar with. We just want to think about a little bit more deeply. So we want to end up where we understand the connection between rate of change and slope of a linear function, identify functions that do not have a constant rate of change, and understand that these are not linear. And we want to be able to find the slope of a line and understand when the slope is positive, negative, 0, and undefined. So finding it, there's a few methods we can use, and we'll walk through those, but we really want to understand whether we're looking at a graph, at some coordinates, or any other information in context, whether we've got a rate of change that's positive, negative, 0, or undefined, and what causes that. So, meet you on page 87. So we've got Margot here, who is a marine biologist. She's preparing to go on a diving expedition to study a coral reef. And as she loads the boat with the supplies she'll need, she uses a ramp like the one shown in the following diagram. Notice the terms rise and run on the diagram. What do you think these terms mean in this context? So Springboard is all about context. What does the information mean in this story relative to Margot and her loading dock? So you put this stuff in your own words, but rise is vertical, has to do with vertical change, something like that, and run is going to refer to horizontal change. And make sure you know the difference between vertical and horizontal. Horizontal goes that way, vertical goes that way. So this sort of puts mathematically what we just talked about in the last slide. It says consider the line in the graph below, and it shows some vertical change here, and that's this part, and it compares it with some horizontal change. That's this part. And it's just showing it in two different sections. This is also a horizontal change right here, and this is also a horizontal change right here. And they say vertical change can be represented as a change in y, because y measures the vertical axis. And horizontal change can be represented by a change in x. We're going to use the delta symbol for change. It's a Greek letter delta. We'll talk about that in a slide or two coming up. So what is the vertical change between points A and B? How much is that changing? It's going up 1, 2, 3. So the vertical change is 3. Between points A and C, it goes all the way from here up to here, which would be this high if I went parallel with C there. So it goes up 1, 2, 3, 4, 5, 6. And how about between C and D? It just goes up 1, 2, 3. We're just talking about vertical change. How much is it going up from C, which would be this high right here, to D? How far is it going up? All right, so then the next part says what's the horizontal change between the same points? So from A to B, it changes 1, 2, 3, 4. From A to C, it changes 4, 5, 6, 7, 8. Yep, 8. And from C to D, it just changes 1, 2, 3, 4. So you can start seeing that the pattern is the same. The reason why it's different between A and C is that we went all the way, we passed by B, so it should be double in both cases. So slope is a measure of the amount of decline or incline of a line. So the variable m is used to represent slope. The ratio, that's always a fraction, the ratio of vertical change to horizontal change determines the slope of the line. So we're going to be looking for a vertical change, horizontal change, and we're going to make a ratio out of them. So that would look like this. Slope is vertical change over horizontal change, also known as change in y over change in x. And this is how we'll start writing it. Delta y over delta x. Delta means change in, so that little symbol means change. So change in y over change in x. So we're supposed to find the slope of the segment of the line connecting points A and B. So we said that the vertical change was 3 and the horizontal change was 4. Between A and C, the vertical change was 6 and the horizontal change was 8. And if we reduce that, we'd still have 3 over 4. And between C and D, it was 3 for the vertical and 4 for the horizontal. What do you notice about the slope of the line in A, B, and C? Hopefully you notice it's always the same. In order to be a line, a linear function, the rate of change has to be constant, has to always be the same. So what does our answer on number 5 indicate about points on a line? They will always have the same slope. So between any 2 points, the slope between any 2 points on a line, now that's important, on a line will always be the same. Hopefully you already knew that about lines, but if not, it's a good refresher or an introduction. So as we go through these problems in the lesson office mixes, there will be times when you hear me mention a problem number that doesn't match what you're seeing in your book. I've tried to make text box comments when that happens. When Springboard updates their new book editions, sometimes they change the order of the problems and the problem numbers, but don't let that bother you. The problems and the numbers inside the problems are still the same. So here we have on number 7, slope is sometimes referred to as rise over run. Explain how the ratio rise over run relates to the ratios for finding slope mentioned above. As you work your way through these mixes, I encourage you to try doing these things by yourself. Pause the mix, put your own response down, then listen to what I say. See if yours was good enough, if there's anything you want to add to it, or if there's something you want to ask me about the next day. So try to avoid just listening and copying and not getting anything out of it. So again, this is, you should feel like we're repeating ourselves a little bit here. Rise is vertical change. I'm going to use this symbol for change, and this is vertical. Run is horizontal change, which is that direction. So the slope m of a line can be calculated numerically using any 2 points, x1, y1, and x2, y2. Also, you can read that as x sub 1, it's a subscript, y sub 1, and x sub 2, y sub 2 on the line. The vertical change in y, of the line through these 2 points is y2 minus y1 or y1 minus y2. The horizontal change, delta x, of the line through these 2 points is x2 minus x1 or x1 minus x2. So to find the difference or the change, we need to subtract our 2 vertical coordinates to find the vertical change and our 2 horizontal coordinates to find the horizontal change. Note that the first x coordinate of the denominator of the slope formula is from the same ordered pair as the first y coordinate of the numerator. So what they're saying is, do you see how they're using the formula here, starting with the sub 2's? So they're doing y2 minus y1. So they have to do the same coordinate on the bottom. They have to start with the second coordinate for the x minus the first coordinate. You can also do it this way. You'll get the same result if you start with the first y minus the second one, but you have to make sure then in the denominator you do the first x minus the second one. So whatever you choose, whichever coordinate you start with in the top, you have to start with in the bottom. here's just a recap that the Greek letter delta represents a change. You'll use that in chemistry, you'll use that in physics, and a lot of other practical sciences. So here is the formula in action here. So if you have a point whose coordinates are x1, y1, and a point whose coordinates are x2, y2, then you can find the change in y by doing either of these things, but you will subtract them. And the same thing for the horizontal change, the change in x. So the x-axis is horizontal, the y-axis is vertical, and you're going to find the change in y over the change in x. So making sure that you start with the same coordinate is really important, or we'll have sign errors in our answer. So we'll go through some of those. For example A, we're going to use the slope formula to determine the slope of a line that passes through the points 5, 6 and -1, 4. So these will be my x1, y1, and these will be my x2, y2. So if we use this formula, y2, 4, minus y1, 6, over x2, -1, minus 5, which is x1. So then we'll reduce, simplify. 4 minus 6 is -2 on top. -1 minus 5 more is -6 on the bottom. A negative divided by a negative gives us a positive number, and we'll reduce that to 1/3. So try these on your own. Pause the mix, try these, and then let's see if you get that right. So if I use the slope formula, I can, if this is x1, y1, x2, y2, I can do 6 minus 2 for my y's over 8 minus 6 for my x's. So I'm always doing change in y over change in x, which is 4 over 2, which equals 2. I could also do it the other way. 2 minus 6 for my y's and 6 minus 8 for my x's, starting with the first point versus the second point. As long as my numerator and denominator start with the same point, I can do it either way. So this would give me -4 over -2, which would still reduce to 2. So either way is fine. And for B, you should get -1 minus 0 over 3 minus -4. So the only time there will ever be a plus in this formula is if you subtract a negative. So that's what's going to cause that. So I'll have -1/7. So signs are king. If kids are going to make mistakes, it's going to be a negative or a subtraction that's messing things up, or they're going to mess up the order of x's and y's. So concentrate on the details. You can do this. So here we're going to be reinforcing that concept that we can start with either point as long as we're consistent with the x's and the y's. So we're using the same line that we did in example A, but now we're going to call this point, these coordinates are the 1's, and these are going to be the 2's this time. So if we show our work, we'd have 6 minus 4 over 5 minus -1. Be careful about that sign. That'll make it turn positive, which will give us 2 over 6, which would still be 1/3. So we can start with the other point as long as we start x and y from the same point. So what we notice about example A and the one we just did is they are the same. And what this tells us about which point to choose for x1 and for the 1's and for the 2's is it doesn't matter as long as I'm consistent for the change in y and change in x. So whichever y I start with, I want to make sure I start with that x. So here's what Anthony did. He computed the slope of the line that passes through these 2 points. His calculation is below. So here's his formula. And he did 3 minus 1 for the y's. So he did y1 minus y2. But then he did negative 2. So he did x2 minus x1. So he did y1 minus y2 over x2 minus x1. And that is exactly what won't work. You can't start with the 1's for the y's and the 2's for the x's. So that won't work. So no, he's not correct. He started with first point for y, but second point for x. And Anthony isn't alone. That's a very common mistake. So he should have done, if he did 3 minus 1, then he should have done 4 minus negative 2, which would be plus. So he'd get 2 over 6, which is 1/3. So you're going to want to try these on your own by pausing the mix, and then check your thinking by playing the mix and seeing how you did. So for this first one, we should have negative 6 minus 9 over negative 8 minus 4, which will give me negative 15 over negative 12, which should reduce to 5/4 positive, because both of those divide by 3. And then here we'll get negative 10 minus negative 3, which will cause a plus. Watch out for that. Over 9 minus negative 5, which is another plus. So that'll give us negative 7 over 14, which will reduce to negative 1/2. Signs are critical. So 1/2 isn't the same as negative 1/2. That line would be going completely wrong direction, down instead of up. Explain how to find the slope of a line from a graph. Well, we're going to find 2 points and determine vertical change over horizontal change. And another way of saying that is rise over run. How is the vertical movement changing as the horizontal movement is changing? And when we're given 2 points, we don't want to take the time to draw a graph, so we're going to use the formula. So our slope will equal the second y coordinate minus the first one over the second x coordinate minus the first one. So we're finding the change in y, or vertical change, over the change in x, or the change in the dependent over the change in the independent variable. So we're going to talk about Aaliyah here, who has saved $375. She wants to buy books that cost $3 each. Those aren't very expensive books. And she wants to write a function, or they want us to write a function, f of x, for the amount of money that Aaliyah still has if she buys x books. So they've told us that x is going to stand for books, and they want function notation. So we're going to have f of x equals, she starts with $375, and every time she buys a book, she's going to spend or decrease her money by $3 per book. So now we're going to make an input-output table of ordered pairs so that we can graph the function. So we know when she buys 0 books, she's going to have $375. Now, they gave me a scale here, which is really nice. It saves me a lot of time. I don't have to create that whole graph from scratch. But if you notice, the graph goes to 500, and she starts with 375, and then you see it's going by, like, each interval here is 25. And so I don't want to go by, I don't want to say when she buys 1 book how much money she'll have, because that's going to be really hard to graph on a scale that's going by 25. So we want to be conscious of that before we make some choices. So let's say when she buys 25 books, how much money will she have left? Well, they're $3 each, so if she buys 25, she spent $75, so she'll have $300 left. If she buys 50 books, that's going to cost her $150 altogether. So she'd have $225 left, and so on. So in increments of 25, figure out how many books she'd have left. So if she bought 75, she would have spent $225, so she'd have $150 left. And if she bought 100 books, she would have spent $300, so she'd only have 75 left. And if she bought 125 books, well, that would cost her her whole $375, so she wouldn't have anything left. So if we graph that, we'd start here, and then we'd have this many. Oh, yeah, that's right. 25 books, and we'd have this much. 50 books, we'd have 225. 75 books, we'd have 150. 100 books, we'd have 75 left. Well, not us, but Aaliyah. And for 125, she wouldn't have any. So the graph would look like that. That's how much money she'd have every time she bought some more books. Now, there's other amounts of books she can buy in between, so we'll go ahead and connect that, because even though she couldn't buy half of a book, if this scale is going by 25s, there's certainly numbers of books in between there that she could buy. She could buy 7 books or just 1 book, so we'll fill that in. Does this function have a constant rate of change? What do you think? Yes, -3. It's going down by -3 every time. What's the slope of the line that we graphed? Well, it's going down -3 for every 1 book. So the slope is -3. Describe the relationship between the slope of the line, the rate of change, and the equation of the line. So we're talking about the slope from the graph, the rate of change from the table, and the equation of the line. So if you look right here, this coefficient of x, those are all the same number. So let's start with the slope of the line. The slope is -3. Rate of change is -3. And from the equation, the coefficient, that's the number in front of, coefficient of x is also -3. They're all the same. So now we're going to describe the meaning of the slope within the context of her savings. So that we know the slope is -3, and in the context of the story, it means how much her savings changes for each book she buys. So we got to be specific about that context. It's not just how much her savings changes, but what's causing it. It's how much her savings is changing for each book. -$3 for each book. How does this differ from the other slopes we've seen in this activity? Well, this one is negative. It seems like all the other ones we've seen have been positive so far, so that's new. So you should try these on your own. I'm going to keep stressing that, but then listen and see how your thinking held up. If the constant rate of change of a function is -5, we want to describe the graph as we look at it from left to right. That's important. We always want to read from left to right. So if it's -5, as I move to the right, this line will be going down by 5. So something like that. It will be going down because it's going -5 for each time I go 1 in x. So one movement in x will cause, well, that's not very much to scale, but 5 drops in y. Does the table represent data with a constant rate of change? Well, let's see. So y, the change in y, this change is 10, and this change is 2. So we have 10 over 2 for that first one, which is 5. Let's see, here it's changing by 15, and this one's changing by 3. So 15 over 3, that would also be 5. But let's see, this one's 20, and this one is 4. 20 over 4 is also 5. So yes, the rate of change is always 5 over 1. So if we reduce those changes, we would always get 5 over 1, 5 over 1, or 5. All right, so number 3 here says the table below represents a function. Okay, they're telling us that it's a function. Every input only has one output. So we're supposed to determine the rate of change between these points. So then remember, that's change in y over change in x. So y goes from 34 minus 62. We have a formula for it. So y2 minus y1 over x2 minus x1, which will be adding, because we're minusing a negative. So that's going to give us negative 28 over 2, which is negative 14. Again, hopefully you didn't just copy that down, but you paused it before I started and you did it yourself, and you made sure you weren't making any little errors. So now so we just did between this point and this point. And now it says determine between these next 2 points. So let's see what happens. So we've got, now be careful, these are all look the same. So y2 minus y1, which is negative 1 minus negative 1, or plus, over 1 minus negative 1, or 1 plus 1, which equals 0 over 2, which is 0. So part C says construct viable arguments. Is this a linear function? Hopefully you're going to say, no, this can't be linear, because the rate of change was different between, different sets of points, or because the rate of change was not constant over all the intervals. Something like that. It doesn't have to be my words, but you have to be able to say that the rate of change changed. It wasn't constant. It was different in different places, so it can't be a line. It's going to bend somehow. So we can write down points and use the formula, or we could find some points here. Looks like that would be good. So we're supposed to determine the slope here. So change in y over change in x. This looks like y goes up 1 when x goes over 1, 2, 3, 4. And then this one, let's see, there's a good spot. There's a good spot. So y always goes on top. The change in y is going up 2 when x goes over 1. So that slope would look like 2. And this one, let's see, here's a spot, and I guess here would be the next one. So that goes up 5 when it goes over 1. So that would be a slope of 5. So express regularity in repeated reasoning. We want to notice something from all 3 of these. And it should help us to describe the slope of any line that rises as you view it from, here's the important part, as you view it from left to right. We always have to think about viewing things as x increases. So as we move this direction across the graph, so starting at the furthest left point, that would be this one, that would be this one, this end, that would be this end. So the tilt of the line sometimes makes it harder to see, but you got to find the furthest left end and read it that direction. So the slope of any line that rises as you view it from left to right, it will be positive. Hopefully you picked that up. The slope will be positive if the line rises from left to right. Let's see, now we're going to find some more slopes. So let's see, this one has a good spot there and there by the looks. And that means y is going 1, 2, 3, down 3. So that means negative 3. It's falling rather than rising is what it's really doing when x goes over 1. So that slope is negative 3. Let's see, this one maybe here and here. So y is going down 2 when x goes over 1. So that's a slope of negative 2. And this one, let's see. Looks like these are our two closest points. So it's going to go down 1, 2, 3. Y is going down 3 when x goes over 4. So we got negative 3, negative 2, and negative 3/4. What do we notice here? To be able to describe the slope of any line that falls as you go left to right, do you notice that the slope will be negative? That is important. All right, so for number 6 here, we're supposed to determine the slope of these lines. So I can pick points here and here, or anywhere on there, but basically the change in y is going to be 0, and the change in x is, if I pick those two, it's just 1. If I picked this one and this one, maybe it's 4, but it doesn't matter because 0 over anything is going to be 0. And so on both of these, can you tell that it's rising 0? If the change in y is 0, then it doesn't really matter what the change in x is, because if I pick those 2 points, that's not a point, but it would still be 0. And you can tell that this one is 0. So hopefully you've just defined for yourself, what is the slope of a horizontal line? 0. All horizontal lines have slopes of 0. Now let's look at these lines here in number 7. So if I pick, let's say, this point and this point, excuse me, the change in y is maybe, I don't know if it's going up or down because I can't tell if I'm going left or right, but let's say it's going up 2. And the change in x is 0. Hopefully you already know this. This has no definition. You can't divide by 0 because dividing is all about how many times the denominator will go into the numerator. So if you look up here at this first one, 1 fits into 0. It doesn't. It won't fit into 0. It fits in there 0 times. But if I look at this one down here, 0 will fit into 2 infinity times. It's not defined. It'll fit in there an infinite number of times, and we can't count that high. So that is an undefined slope. And so all of these, they're rising, but they're not running. So if we're dividing by 0, that's going to be undefined. And so is this one. They're all going to be undefined. So if you end up dividing by 0 when you're doing a slope because the x is not changing, then the slope of any vertical line is going to be undefined. And it might be good to write that sentence out. The slope of any vertical line is undefined, because that working of your pen and your hand will help it go into your brain. All right, so here are a few takeaways we want to make sure we got here. Summarize our findings in item 20. Tell whether the slopes of the lines described in the table below are positive, negative, 0, or undefined. So look back at those ABCDs that you just did. If it's going to go up from left to right, so if the graph looks like this, then that slope is positive. If it goes down from left to right, so like this, the slope's negative. Horizontal, the slope is 0, and vertical is when you're not running, so you're going to divide by 0. You're only rising, and you can't divide by 0, so that would be undefined. Boy, those are important to know. So try these, check your understandings, pause me, and then see how you did. Suppose you're given several points on the graph of a function. Without graphing, how could you determine whether the function is linear? What makes a function linear? It's really, really, really important. See if there is a constant rate of change. If I ask you what makes something linear, a function linear, I need you to tell me it has a constant rate of change. It's always changing by the same amount. That's what makes it stay in a straight line. How can you tell if it's positive or negative? If you're looking at a graph, read left to right. Make sure you're always reading this direction and see if it rises, that would be positive, or falls, that would be negative. Describe a line having an undefined slope. Undefined slope would be a vertical line because it's not running. No run value. So you would be dividing by what causes that to be undefined? 0. You can't divide by 0. All right, guys, that was a lot of thinking about slope. So we'll pick this up in class where we'll get any questions answered and you'll have a chance to get your lesson practice done. See you there.